To accommodate an Edison Ground Cap, abbreviated EGC, on older cord-hung fixtures that use metal tube sockets, there's a specific method to follow for safe and effective grounding. The first step is to disconnect the electricity. This means turning off the power to the light fixture, the circuit breaker or the fuse box to ensure there is no live current running through the wiring. The next step involves removing the old socket. Carefully unscrew the old socket from the metal tube. This might require some patience, especially if the socket has been in place for a long time. Once the old socket is removed, it's time to install an adapter. You will need to purchase an adapter specifically designed to convert a metal tube socket to accommodate an EGC. Screw this adapter securely into the metal tube. Ensure the adapter is compatible with the metal tube's threading. Next, connect the EGC itself. Screw the EGC onto the adapter that you just installed. Make sure it is tightly secured to ensure a good electrical connection. Following the EGC connection, install the new socket. Screw the new socket onto the EGC. This new socket should be compatible with the EGC and designed for grounded connections. Finally, reconnect the electricity. Turn the power back on at the circuit breaker or fuse box and then test the light fixture to ensure it is working correctly. Verify that the fixture is now properly grounded. It is important to remember to ensure that the adapter and the EGC are compatible with both the socket and the metal tube you are working with. Incompatibility can lead to unsafe conditions and ineffective grounding. If you are not comfortable performing electrical work, it is strongly recommended to hire a qualified electrician. Electrical work can be dangerous, and a professional can ensure the job is done safely and correctly. Additionally, contact your local building code authority to inquire about any specific requirements or regulations regarding electrical grounding in your area. Local codes can vary and adherence to them is crucial for safety and compliance. This ensures that the installation meets all legal and safety standards. Furthermore, it is important to choose the correct size EGC wire. The appropriate gauge of the grounding conductor is determined by the size of the circuit's overcurrent protection device, such as a circuit breaker or fuse. Refer to the National Electrical Code, specifically Table 250.122, to determine the minimum size of the grounding conductor based on the rating of the overcurrent device protecting the circuit. For example, if the circuit is protected by a 15-amp breaker, a 14 American wire gauge, abbreviated AWG, copper grounding conductor is generally sufficient. If the circuit is protected by a 20-amp breaker, a 12 AWG copper grounding conductor is commonly used. For larger circuits, such as those protected by a 30-amp or 40-amp breaker, a 10 AWG copper grounding conductor may be required. Always consult the NEC Table 250.122 for the specific requirements based on the overcurrent protection device rating. When connecting the EGC, ensure that all connections are secure and properly tightened. Loose connections can create resistance, which can impede the flow of fault current and compromise the effectiveness of the grounding system. Use appropriate connectors and terminals that are listed for the purpose, and torque them to the manufacturer's specifications. This ensures a reliable and safe electrical connection. Additionally, consider using a multimeter to test the continuity of the grounding path. After installing the EGC, use a multimeter to measure the resistance between the metal parts of the fixture and a known good ground, such as a grounding electrode conductor or a metallic water pipe. The resistance should be very low, ideally less than 1 ohm, indicating a solid and continuous grounding path. If the resistance is high, it indicates a problem with the grounding connection that needs to be addressed. Check all connections and ensure they are clean and tight. If the metal tube socket is connected to a metal enclosure or junction box, ensure that the enclosure is also properly grounded. The enclosure should be connected to the building's grounding electrode system with a grounding electrode conductor. This ensures that any fault current will have a low impedance path back to the source, allowing the overcurrent protection device to trip and clear the fault. If the metal tube socket is mounted on a non-conductive surface, such as wood or plastic, it is still important to provide a grounding connection for the metal part of the fixture. In this case, you can run a grounding wire from the metal tube socket to a nearby grounding point, such as a grounded metal junction box or a grounding electrode conductor. This provides a path for fault current to flow back to the source in the event of a fault. When working with older wiring, it is common to encounter cloth-insulated wires. Cloth insulation can deteriorate over time, becoming brittle and cracked. If the cloth insulation is damaged, it can expose the bare conductors, creating a shock hazard. It is important to carefully inspect the wiring and replace any damaged or deteriorated insulation. You can use electrical tape or heat shrink tubing to repair minor damage. For more extensive damage, it may be necessary to replace the entire wire. When replacing wiring, use appropriately rated conductors that are suitable for the application. Ensure that the new wiring is the same gauge as the original wiring, or larger if necessary to meet the current carrying requirements of the circuit. Also, ensure that the new wiring is rated for the voltage and temperature conditions of the environment. When making wire connections, use appropriate wire connectors that are listed for the purpose. Wire connectors should be sized correctly for the number and gauge of the wires being connected. Ensure that the wire connectors are tightened securely to provide a reliable electrical connection. Do not over-tighten the wire connectors, as this can damage the wires or the connectors. Use a torque wrench to tighten the wire connectors to the manufacturer's specifications. If the light fixture is located in a damp or wet location, such as a bathroom or outdoor area, it is important to use a light fixture that is rated for wet locations. Wet location rated fixtures are designed to prevent water from entering the electrical components and causing a shock hazard. These fixtures typically have sealed enclosures and gaskets to protect against moisture. When installing a wet location rated fixture, ensure that all connections are properly sealed to prevent water intrusion. Use waterproof wire connectors and seal any openings with silicone caulk. Additionally, consider using a ground fault circuit interrupter, abbreviated GFCI, protected circuit for light fixtures located in damp or wet locations. GFCIs are designed to detect small amounts of current leakage and trip the circuit, preventing electric shock. GFCIs are required by the National Electrical Code in certain locations, such as bathrooms, kitchens, and outdoor areas. When installing a GFCI, follow the manufacturer's instructions carefully. Test the GFCI regularly to ensure that it is functioning properly. If the light fixture is controlled by a dimmer switch, ensure that the dimmer switch is compatible with the type of light bulb being used. Some dimmer switches are not compatible with LED or compact fluorescent light bulbs. Using an incompatible dimmer switch can damage the light bulb or the dimmer switch. Check the manufacturer's specifications to ensure that the dimmer switch is compatible with the light bulb. When replacing a dimmer switch, ensure that the new dimmer switch is rated for the wattage of the light fixture. The dimmer switch should be rated for at least the total wattage of all the light bulbs in the fixture. If the dimmer switch is not rated for the wattage of the fixture, it can overheat and fail. When working with electrical systems, it is always important to follow safe work practices. Wear appropriate personal protective equipment such as safety glasses and insulated gloves. Use insulated tools to prevent electric shock. Work in a well-lit area and avoid distractions. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Remember, safety should always be the top priority when working with electrical systems. Before commencing any electrical work, it's crucial to verify that the circuit is indeed energized. Use a reliable voltage tester to confirm that no voltage is present on the wires you intend to work with. Test the voltage tester on a known live circuit before and after testing the circuit you're working on to ensure that the tester is functioning correctly. This practice is known as dead live testing, and it helps prevent accidental electrocution. After disconnecting the power and verifying the absence of voltage, consider placing a lockout-tagout device in the circuit breaker or fuse box. A lockout-tagout device physically prevents the circuit breaker from being turned back on while you're working on the circuit. This provides an additional layer of safety and helps prevent accidental energization of the circuit. When selecting an adapter for converting the metal tube socket to an AGC, choose an adapter that is specifically designed for that purpose. Do not attempt to modify or adapt other types of fittings, as this can compromise the safety and effectiveness of the grounding system. The adapter should be made of durable, corrosion-resistant material and should be listed by a recognized testing laboratory, such as Underwriters Laboratories, abbreviated UL, or Intertek, abbreviated ETL. Ensure that the adapter is properly sized for the metal tube and the EGC conductor. The adapter should provide a secure and reliable connection for the EGC conductor, ensuring a low impedance path for fault current. When connecting the EGC conductor to the adapter, use a grounding screw or lug that is specifically designed for that purpose. The grounding screw or lug should be made of corrosion-resistant material and should be sized correctly for the EGC conductor. Ensure that the grounding screw or lug is tightened securely to provide a good electrical connection. Do not over-tighten the grounding screw or lug, as this can damage the wires or the adapter. If the metal tube socket is corroded or damaged, it may be necessary to replace the entire socket assembly. When replacing the socket assembly, choose a replacement that is made of durable, corrosion-resistant material and is listed by a recognized testing laboratory. Ensure that the replacement socket assembly is compatible with the existing light fixture and wiring. Follow the manufacturer's instructions carefully when installing the replacement socket assembly. When working with older light fixtures, it is common to encounter asbestos-containing materials. Asbestos was commonly used in electrical insulation and other components of older light fixtures. If you suspect that a light fixture contains asbestos, do not disturb the material. Asbestos fibers can be released into the air when the material is disturbed, and inhaling asbestos fibers can cause serious health problems. Contact a qualified asbestos abatement contractor to remove the asbestos-containing material safely. When disposing of old light fixtures, follow local regulations for disposal of electronic waste. Electronic waste, also known as e-waste, can contain hazardous materials such as lead, mercury, and cadmium. These materials can contaminate the environment if they are not disposed of properly. Many communities have designated e-waste collection sites where you can drop off old light fixtures for recycling. Check with your local waste management authority for more information on e-waste disposal. After completing the electrical work, thoroughly inspect the light fixture and wiring to ensure that everything is installed correctly and safely. Check for any loose connections, damaged wiring, or exposed conductors. Use a flashlight to inspect hard-to-reach areas. If you find any problems, correct them immediately. Finally, test the light fixture to ensure that it is working properly. Turn on the power and check that the light bulb illuminates. Test any dimmer switches or other controls to ensure that they are functioning correctly. If the light fixture does not work properly, troubleshoot the problem and correct it before using the fixture. Remember, electrical work can be dangerous, and it is important to follow safe work practices at all times. If you are not comfortable performing electrical work, hire a qualified electrician to do the job. Safety should always be the top priority. When dealing with antique or vintage light fixtures, it's crucial to preserve their historical integrity while ensuring electrical safety. Consider consulting with a restoration specialist who has experience working with antique lighting. They can advise you on the best methods for grounding and rewiring the fixture while maintaining its original appearance. If the existing wiring in the fixture is severely deteriorated, it may be necessary to replace it entirely. When replacing the wiring, use wire that is as close as possible to the original in terms of gauge, color, and insulation material. This will help maintain the fixture's authenticity. Consider using cloth-covered wire, which is available in a variety of colors and patterns to match the original wiring. When replacing the socket, choose a socket that is similar in style and appearance to the original. There are many reproduction sockets available that are designed to look like antique sockets. Ensure that the replacement socket is listed by a recognized testing laboratory and is rated for the voltage and current of the circuit. If the fixture has a canopy or other decorative element, be careful not to damage it when working on the wiring. Use appropriate tools and techniques to remove and reinstall the canopy without scratching or denting it. If the canopy is made of delicate material, such as glass or porcelain, consider having it professionally cleaned and restored. When grounding the fixture, try to conceal the grounding wire as much as possible. Run the grounding wire through the fixture's stem or chain and connect it to a grounding point inside the junction box. This will help maintain the fixture's aesthetic appeal. Consider using a small, unobtrusive grounding clip to connect the grounding wire to the fixture's metal component. These clips are designed to provide a secure grounding connection without being visible. If the fixture is suspended from a chain, ensure that the chain is also grounded. Run a grounding wire through the chain and connect it to a grounding point inside the junction box. This will help prevent the chain from becoming energized in the event of a fault. When working with antique light fixtures, it's essential to document your work. Take photographs of the fixture before, during, and after the restoration process. Keep a record of all the parts and materials that you used, as well as any changes that you made to the fixture. This documentation will be helpful if you ever need to repair or restore the fixture in the future. Remember, restoring an antique light fixture is a delicate process that requires patience and attention to detail. Take your time and do the job right, and you'll be rewarded with a beautiful and safe light fixture that will last for many years to come. The National Electrical Code, abbreviated NEC, is a comprehensive set of standards for electrical wiring and equipment in the United States. It is updated every 3 years by the National Fire Protection Association, abbreviated NFPA. The NEC covers a wide range of topics, including grounding, wiring methods, overcurrent protection, and equipment installation. It is essential for electricians and other electrical professionals to be familiar with the NEC and to follow its requirements when performing electrical work. The NEC is organized into chapters, articles, and sections. Each section contains specific requirements for electrical installations. The NEC also includes tables and examples to help clarify the requirements. The NEC is not a law, but it is often adopted by state and local governments as part of their building codes. In many jurisdictions, electrical work must be performed in accordance with the NEC. Failure to comply with the NEC can result in fines, penalties, and even criminal charges. The NEC is a valuable resource for anyone who is involved in electrical work. It provides a comprehensive set of standards that can help ensure the safety and reliability of electrical installations. Consider investing in a copy of the NEC and taking the time to study it. This will help you become a more knowledgeable and competent electrical professional. Always consult the latest edition of the NEC for the most up-to-date requirements. Electrical codes can change over time, so it's important to stay current with the latest standards. Consider subscribing to an electrical trade publication or attending electrical training courses to stay informed about changes to the NEC. Grounding is a critical aspect of electrical safety. It provides a path for fault current to flow back to the source, allowing the overcurrent protection device to trip and clear the fault. This helps prevent electric shock and fire hazards. A properly grounded electrical system also helps to reduce electrical noise and improve the performance of electronic equipment. There are 2 main types of grounding systems: equipment grounding and system grounding. Equipment grounding is the connection of non-current carrying metal parts of electrical equipment to ground. This includes metal enclosures, conduits, and junction boxes. System grounding is the connection of the neutral conductor of an electrical system to ground. This helps to stabilize the voltage and provide a low impedance path for fault current. The grounding electrode system is the means by which the electrical system is connected to the earth. It typically consists of a ground rod, a ground plate, or a metal water pipe that is buried in the ground. The grounding electrode system provides a path for fault current to flow into the earth. The grounding electrode conductor is the wire that connects the electrical system to the grounding electrode system. It should be sized according to the requirements of the NEC. The grounding electrode conductor should be made of copper or other corrosion-resistant material. It should be installed in a protected location to prevent damage. Regular maintenance of the electrical system is essential for ensuring its safety and reliability. Inspect the electrical system regularly for any signs of damage or deterioration. Check for loose connections, frayed wires, and cracked insulation. Repair any problems immediately. Have the electrical system inspected by a qualified electrician every few years. The electrician can perform a thorough inspection of the system and identify any potential problems. The electrician can also test the grounding system to ensure that it is functioning properly. Regular maintenance can help to prevent electrical hazards and extend the life of the electrical system. If you have any questions about electrical safety, consult with a qualified electrician. An electrician can provide you with expert advice and guidance on how to keep your home or business safe from electrical hazards. Remember, electrical safety is everyone's responsibility. By following safe work practices and maintaining your electrical system, you can help to prevent electrical accidents and save lives.